In this lesson, you will learn how to add and subtract polynomials and complex numbers. We're first going to start with subtracting. So we have y squared plus y minus 1. We're going to subtract negative 2y squared plus y plus 1. So we have a trinomial because it has 3 terms. We're going to subtract another trinomial, again, because it has 3 terms. So first, rewrite the first parentheses as it is. It will not change. Just write it on the next line. Because this is a subtracting problem, we will want to distribute this negative, and it's really understood to be a 1, distribute this negative 1 to each term in the second parentheses so we can have our signs as the correct positives or negative before we start combining. So negative times negative gives us a positive 2y squared. Negative times positive gives us a negative y. And then negative times positive, again, a negative 1. So once you distribute that negative 1, it's just as simple as combining like terms. We look for the same variable with the same exponent. So y squared plus 2y squared, this is really 1. So 1 plus 2 is 3y squared. When you combine like terms, your answer is that like term. So if you combine y squared terms, you still have a y squared answer. Moving on, we look for our next term. We have a y minus a y. This is 1y, and if we subtract 1y, those actually cancel one another out. And then our final answer, our final terms, we have negative 1. We're going to subtract 1. Negative 1 minus 1 gives us a negative 2. So there's our answer. It actually ends up being a binomial because we had terms that canceled out. So our answer is 3y squared minus 2. Let's look at another subtracting problem. Here we have 2q squared minus q minus 8. We're going to take that trinomial and subtract 2q squared plus q minus 4. So again, the first parenthesis stays as it is. 2q squared minus q minus 8. And it's fine to keep the parentheses or not, but around the first polynomial, they're not necessary any longer, so you can drop those parentheses. Remember to distribute a negative 1 to each of your terms in the second parentheses so you can get your signs correct before combining. So negative times positive makes that a negative 2q squared. Negative times positive, we again have a negative q. And negative times negative makes it a positive 4. Now combine your like terms. We have 2q squared minus 2q squared, so those actually cancel one another out. We have a negative q minus q. Those are actually 1s, so negative 1 minus 1 gives us a negative 2q. And then finally, we have negative 8 plus 4. That gives us a negative 4. So there, when we subtract, we get negative 2q minus 4. Let's look at one more subtracting, number 3. We have 17 minus 6i that we're going to subtract with 9 minus 10i. These are complex numbers, remember a plus bi form, and we are subtracting. Even though this is a binomial and another binomial, notice the sign in between. Some students see binomials and automatically think you multiply, but look at the symbol between those binomials, and it clearly says that we should be subtracting them. So our first parenthesis stays 17 minus 6i. We're going to distribute a negative 1 and making that negative 9 plus 10i. A negative times positive gives us a negative, and a negative times a negative gives us a positive. So once you distribute the negative 1 to the second parentheses, you're ready to combine like terms. Do the constant terms first, so you get your a plus bi form. So 17 minus 9, that gives us 8. And then we have negative 6i plus 10i. That gives us a positive 4i. Because this is a complex number, it needs to be in the form a plus bi. Let's look at some addition problems. We have 5x squared plus 2x minus 1. We're going to add 4x squared minus x plus 2. Because this is addition, you're just ready to combine your like terms. So these parentheses are not even necessary. You could rewrite the problem by removing the parentheses or just go ahead and combine the like terms. It will not be necessary to distribute a positive 1 because it won't do anything to that second parentheses. But if it helps you, feel free to do it. That way you can always remember distributing something if you think that would be best for you. But we're going to just rewrite it by dropping the parentheses. If you don't need this step of rewriting, feel free just to combine your like terms. So we have a 5x squared and a 4x squared. That gives us 9x squared. Again, stressing that when you combine like terms, your answer is that like term. So you will not make it anything other than an x squared. We have a 2x and a negative x. That's negative 1x. So 2 take away 1 is a positive 1, or just x. And then finally we have negative 1 plus 2, which gives us a positive 1. The 1 is not necessary to show in front of the x. However, this last one is necessary because that is the only thing there is. There's no variable with that 1. Let's look at our final example, number 5. Here we're going to add some complex numbers. So negative 7 plus 2i, we're going to add that with 5 minus 11i. So again, even though this is a binomial and a binomial, notice the symbol between the binomials. It's telling us to add them, not to multiply them. Many students make the mistake just because they're binomials, they feel like they should multiply. Pay attention to the sign it tells you to add. So feel free to rewrite the problem if you need, but because it's addition, you can just really ignore those parentheses and start combining your like terms. We have negative 7 plus 5, which gives us a negative 2. And 2i minus 11i, which gives us a negative 9i. It's a complex number, so it's in the form a plus bi. I know it really says minus, but plus and negative is the same. So this is in the correct form, a plus bi.